There we go. All right, beautiful, beautiful. Okay. Okay, so we get the mean. Okay. What I did here was, although I guess really, well, yeah, I listed all the data in one column. I listed the data in one column, okay? If we were given a frequency table instead of the data directly, this would be a little bit different, but not much. For now, this is what we're doing. Next, as you can see, I'm taking each data value and subtracting the mean. Subtracting the mean. So really then what the standard deviation actually is, you're seeing how much variation there is relative to the mean. That's really what it is though. But that's what we're doing. So we subtract each data value from the mean. We get all the entries here. This is step 2. This step is step 3. We're squaring. We're squaring each of these differences is what we're doing. So we have minus 3 squared, as you can see, right? What's nice about this is, if you by mistake, instead of doing 1 minus 4, if we did 4 minus 1, it really doesn't make a difference because we're squaring. If we did 4 minus 1, instead of a negative 3, we would have a 3. But a number and its negative have the same square. So this is what we have here. Okay, so again, this is step, let me get back to it. This is step 3. We squared each difference. Now we're going to add up. We're going to now add up these squares, right? I think actually in the steps I listed, I wrote subtract the data value from the mean. But again, it's okay if we did this because we're squaring. So from here, right, we're going to add up these values. That's what we're doing here. Adding them up, what do we get? 36. And now remember, this is step 4. So step 5, we have to divide. Now here, this is sample data. So we're going to divide by n minus 1. N is how many data values there are. Okay? We're dividing by n minus 1, where n is how much data there is. So in this example, n is 10, right? So we're dividing by 9. And we get 4. And this is what I was saying before. This is the variance. The variance of this data is 4. I mean, I don't know what the units for this are, but for now that doesn't matter. This is what the variance is. The standard deviation is 2. And the square root of that. So that's our example of standard deviation. I probably should have said this before, but the bigger the standard deviation is, the more widespread the data is, the more variation there is relative to the mean. The more spread out the data is, in other words. That's why I should have said that before, but I'm saying it now. So we'll get to another example. Are there any questions about this example? I can't see the chat, so I really shouldn't have to do this, but okay. Well, I hope they come back. All right. All right. Okay. All right. Good. Okay. Okay, so that's one example. Let's do another one. So here's another sample. Okay. Again, I just kind of pick these numbers randomly. Here, notice the data is already sorted, although really you don't have to sort the data when you're trying to calculate standard deviation. I mean, you could if you wanted to, but you don't have to. Okay. So now, right? So now again, we want to get the standard deviation. I mean, I'm saying it here, but again, this is sample data. Okay, so what is the mean? That's the first thing we calculate, right? We just add up the data values, divide by how many there are. Okay? I mean, if we counted right, which I hope I did, it is 12. We get 90 over 12, which is 7.5. That's our mean. All right, now here, okay? So again, we got the mean. What do we do next? We list, so I made this table as in the previous example. I mean, technically you don't have to. I just thought it keeps the data more organized. So I listed all data, as you can see, including repetition. Okay, you have to take that into account. So what do I do next? I'm subtracting the mean from the data value. I could go the other way. In fact, I think I wrote down actually subtract the data value from the mean, but it really doesn't matter because we're squaring. So we have -1 minus 7.5, which is this. I subtract each data value. I do each data value minus the mean, as you can see. Getting all these wonderful numbers here. Then I'm squaring, as you can see. Now, also, these I did using a calculator. So, I mean, I didn't want to waste, not waste time, but I didn't want to have to calculate this by hand. So I used the calculator for this. Now, so we have that. Remember, the next thing we do is we have to add up these entries, right? The squares, we add up the entries. Once we add up these entries, we're going to get 595. You know, these are all positive. Keep in mind, these are all non-negative. So when you add up the entries here, you should not get a negative. All right. This is sample data. Remember, unless stated otherwise, it's always sample data. So we're dividing by 12 minus 1, which is 11. N is 12. We always divide by n minus 1. If it was population data, we divide by 12. Doing so, we get this. So I rounded to 2 decimal places. I would normally tell you how many decimal places to round to. So here we get 54.09. That's the variance. The standard deviation is this, 7.35. Good. Okay, so that's one example. So that's another example. Do you have any questions about this one? Okay, so because I had the next example, I want everyone to try. So as before, what you're going to do that is you know, you have this data, you're going to find the mean. Then you're going to find the standard deviation. Now what I'm going to do is I'll give you about between 5 and 7 minutes to do both. I mean, if you don't finish, that's okay. But I really want everyone to take a shot at it. So let me just stop the recording.